In this part of the tutorial, we will create our walls for our HCA, and also after the wall creation, we will create our trims around the doors and windows. So after this part is done, we will basically be done with creating of the geometry for this HCA, and after that we will have to do just clean this up and add some UVs. So let's get to it. And now let's create walls for our building. So I'm going to start by dragging out our initial group setup from here to maybe something like this, and put down a match size node. So in this match size, I want to reference my initial framing of the geometry, which is this node. So basically, we want to make sure that our walls cover everything inside here, from top to bottom. And to make sure that actually the scaling is correct, what you can do is reference this geometry in our match size node. So actually, I'm going to use object merge node. So because I do not want to cross these wires too much, I'm just going to select this node like that. And if you're using one of my tools, you can easily object merge nodes in a network. And now in this match size, I want to make sure that I translate on the center only the y-axis. X and Z is not going to do anything. Scale to fit, turn off uniform scale, and I just want to also scale on the y-axis. So in this match size, I just want to make sure that on the y-axis we are actually matching exactly, because the other axis we will do it with the extrusion once we have made the cutouts for our geometry. So for now, this is our setup, and let's actually put down the blast node before we're actually going to start creating our cutouts for our doors and windows. Let's delete our ceiling and also the floor group, because we need only the walls. For our cutout, let's go to our door and window setup. So you just have to do a little bit of a network cleanup and set this all up. So what I'm going to do is basically get our box, which is basically this one, that we are actually creating our window from. I also want to make sure that we also copy this box along with our window and our stud frame together. And then we're going to just blast it, split it from the stud frame and our cutout in different geometries. We're going to use only our cutouts as a boolean for our walls. So for that, actually, let's go put down a clean node. So let's start cleaning up the geometry. So after this merge, so this merge is really going to, let's disconnect from this merge our walls, our windows. So this merge is only going to be our stud wall geometry. Let's clean it and let's remove groups like that. So basically there's no more groups, and let's actually create a group node. Let's call this, make sure it's primitives. Let's call this stud frame like that. Let's color this clean red like that. So for our windows, what we do is basically do the same thing. So there's a lot of groups from our geometry. So just go ahead, copy this also. We can actually basically just copy this, and let's actually do this inside here like that. Just clean this geometry up from groups and give it its own group, so then we can reference it. And let's do the same for our basically our window group. Just go ahead, copy the network. Let's put it after our group setup inside here. Delete those groups and give it a stud. The name is going to be cutout like that. So for the connection of it, we want to make sure that this is connected, and want to merge all of our group setups. So once we have given all of these its own group, we want to merge them together and give it our string name attribute, because this is what actually controls the copying. So select all of these, so something like this. And then let's take this all and merge these together and put it inside the merge. This one didn't want to merge like that. And then give it this string attribute frame, and basically our copied point should basically now copy also our cutouts with all of our geometry. And let's do the same for our doors too. So I'm just going to skip this ahead. And for doors, it's basically the same setup. And so let's go back to our copy to point. And our copy point should look something like this. And now what we're going to do is go ahead, since we set up our groups, we can put down a split node. And you just want to split by our group. So this is going to be our cutout group. You can see we have basically, let's invert this, like that. Basically got in the same setup as for our copied points as before. But what's cool about this, we also got our cutouts inside here. So what we do is go ahead and put down a boolean node. So inside here, put down a boolean and your split, something like this, and just put it inside a boolean. So we want to make sure that our set A group and B is actually so our B, the incoming is actually a solid, but our A is actually a surface because we have no thickness for our walls right now. And you can see these are our cutouts for our walls, like that. And now let's make our walls fit our geometry. So I'm going to template this one, and let's actually put on a poly extrude. So in this poly extrude, I want to make sure that my wall extrude is going to start from the from basically where our studs end. So what I'm going to do is basically right now our box is splitting across our studs. So just copy the width of our studs, and for extrude just paste inside here and divide it by 2, like that. And now our wall is intersecting with this all very nicely. And let's not output this side because we're going to only now extrude it. So put down the poly extrude again. And for our wall thickness, let's use our thickness parameter, which we use for our gable. Just copy that and paste inside, like that. And let's go ahead and also output the back. Let's connect this to our overall merge, like that. And this should be our wall, like that. And we can also make a little bit separation between our gable and our wall. So actually, let's bevel our wall. So what I'm going to do is, right now, since our gable and bevel use the same extrude, you can see it's basically flush with each other. So let's go back to our poly extrude. And let's actually output our group side group. Let's call this side group, that's fine. And let's group promote. And in this group promote, I want to convert this group, our side group, to the edge group, and I want to make sure that include all elements on the boundary. So this is going to give us a good edges that's going to be that we're actually going to go ahead and bevel. So put down the bevel node. Let's call this wall bevel, like that. Just connect this up. I'm actually going to use our wall bevel. And let's actually add this also parameter to the to our wall controls, to our HDA. And let's actually, and also let's use this wall bevel parameter also on our gable. So let me set this up. So let me delete this one, and let's merge it, our bevel, together. So you see, we're getting a really nice bevel. And you can see that now we have a little bit more of separation between the gable and the wall. So let me set up this also for our gable and continue work on this one. And to add the bevel for our trim, all you have to do is go ahead and copy this poly bevel for our wall and paste it inside where we basically extrude our gable, and basically add the same poly bevel node, like that. And then you can basically just go ahead and add this to our HDA parameter. So under the wall controls, we have a bevel mount. Just copy the parameter. So I have this already linked up to my wall. Just go ahead and also link this up to our bevel inside here, like that. And at the end of it, you should basically get the consistent bevel between the edges, like that. So that's good. And now what we need to do is go ahead and create our trims for the corners, and then also create our trims around the doors and windows. And then we'll be basically done with the geometry part of it, and then we just go to UV unwrap it and add some materials to it. So for the let's start working on our corner trims. So what I'm actually going to do is go ahead and copy this match size node, because I want to make sure that my trim starts from the edges of this one. So before I bevel our geometry, so basically this one, I want to match size it. So let's actually go ahead and connect before the poly bevel our walls, because we want to get dimensions of our walls. And let's go ahead and take our blasted walls to a match size like that. And let's use our match size. Basically, let's just scale to fit, and make sure to scale on X, Y, and Z axis, and justify by Y like that. And this should basically give us the give it the same geometry, only it has no thickness, and we will be able to get our trims. So put down the bevel node, and this bevel, it's automatically going to start to bevel it like that. What we'll do is make sure that we use a solid bevel, and division is going to be 2, and this parameter is going to choose how big of a trim we want for our corners like that. And also want to make sure that we also edge fillet polygon group create, and then just blast it. So we blast it, so our edge fillet polygons, that's going to be primitives. You can see these are basically our trims, and we can just use a poly extrude like that. We can do it something like this, and we can also output back, and then we can extrude bevel it just a little bit amount, so we could add this bevel amount to the basically the same amount that our wall has, but I think for our corner trims we should even bevel it less than. So we're going to add a different parameter for our corner bevels and our wall bevels. It's going to be 2 different bevel amounts. So, but this is basically the simple setup for our trims. So let's go ahead and maybe add it inside here and merge this together also. So these are corners. For our trims around the doors and windows, let's go back to our initial boolean shape where we created our shapes cutouts in our walls, and let's create our output edge group AB seams like that. And let's put down a convert line node, and I found this is probably the best way for us to get the predictable normals on our polylines. So in convert line, use a group AB seams like that, and this should give us these points, and also, but most importantly, these polylines. So put down a clean node, and this clean node is basically going to automatically clean up any points that are not connected to anything like that. Now let's before we start to extrude it, we want to make sure that we actually we do not want our trim to be on our door bottom. So basically want to dissolve this edge. So for that, let's put down a group node. So in our group, let's make sure that this is a edge group. Let's name this let's call this bottom edge, sort of like this. And let's do this by not by base group but by boundary region. And for us to procedurally do it, we just have to set up a couple of expressions. So for the size of it, we want to make sure that it's the size of our bounding box. So it's going to be a bounding box. So this is going to be D, so X size, like that. Then just copy it for the Z also, only the Z size, like that. And for our size on the Y, we want to make sure that it has no size, so make it 0. So for the centroid, put down for our center, put down centroid. So it's going to be our center of the X. So the X, like that. Let's copy for the Z also, except for the X and Z center. And for the center on the Y, we want to make sure that it's at the bottom of our geometry. So that's going to be a bounding box 0. That's going to be dy min, like that. And this will make sure that our bounding box is always sit at the bottom of it, and it's going to be enough size for it to capture the bottom edge. And if we put down the dissolve node and dissolve our bottom edge, and after that we can start to extrude our polyline. So put down the poly extrude. So inside here, you can see it's not working very well because I actually forgot to turn on our convert line to connect the path, like that. So after that, we should now get our polylines, and I want to extrude it outwards because inwards we have already our window in. So this is the parameter that we can add to our HDA to how much we want to actually extrude, how thick, how wide we want our trim to be. Let's actually put down a reverse node because I want to extrude it outwards. So put down a reverse. Let's reverse our normals and let's put down under extrude. It's going to copy it like that. And this is how wide we want our what's the thickness outwards the walls we want our trim to be. So these two parameters we're going to want to add to our HDA. And let's actually merge this together and take a look at how it looks. So you can see there's going to be one problem. So you can't really see it now, but our trim basically intersects, is right on top of our wall. So what I'm do is actually make sure that our trim is a little bit big, goes also a little bit inside our outwards out of our wall. So after our poly extrude outwards, what you can do is actually go ahead and get our polygon boundary group back seam. And our back seam should basically be the edges that we actually started to extrude from. So that put down another extrude, and let's use this. Let's turn off this for this one, and use this group as our extrude and invert. So basically, I want to extrude by a very small amount. So I won't probably even add this to our HDA as ability to change it. So just very small amount so that we do not intersect with our wall. So now we can reverse it and we can dissolve flat edges on this, something like this. Actually, let's actually dissolve it by the group. So our poly extrude, let's output our back seam. It should be basically the same one as this one. And let's dissolve it. So our back seam. So we have basically extruded it and dissolved this edge like that. Then we can reverse it and poly extrude again. And also let's output also the back on it like that. And once you have added controls to your HDA, it should look something like this. So what I did is create a new folder for our trims, and I basically separated my window and door trims with our corner trims so that they can be different size. So let's take a look at our trims for our windows. So I went to our door width of it, trim width like that, and then the size like that. So the 0 size should basically means that the trim is at the wall level, and we can do it by after we have reversed it, putting down the peak node, which is basically moving towards the normal direction of the primitives, and pasting your basically the stud bore width divided by 2. So that means that we start off at the wall level, and then you can just add our wall thickness to our poly extrude to make sure that basically we are extruding, we are always extruding to the wall level on our poly extrude, and then we are adding this wall door thickness to it like that. So if this is 0, you can see that basically our base extrude is going to be at the wall level. You can see that it's intersecting. So we have to add it to add a little bit more of a trim around it. So yeah, so that's for the trims for the doors, width and amount of it, and for the corners is basically the same thing. The width of it, then the amount of what's the thickness for it, the trim. Something like small. Couple more improvements we can make for our HDA. So first of all, for our bevel control, so what I did is actually went ahead in our HDA, set up this special folder which is going to basically control our bevels. And so I end up with 4 different bevel amounts, which is basically for our wood, our roof, our wall, and our bevels for our corners. So let's take a look at what every one of these corners bevel does. So for our corner bevel, door, window, corner bevel, you can see basically going to our trim bevels, going to modify, and also for our roof also. So that's one. So for a wall gable, so we already set this up, which is basically this one, separation between our walls and the gable. This is another bevel. So for our wood, which is basically everything that's structure for our roof, which is inside here, so that's a bevel amount, and also for our wall structure, which is just a bevel inside here, and I just put down a bevel and I bevel it, everything in it like that. And then there's also roof bevel. So on a roof, just general roof, basically the roof bevel like that. So I added these roof bevels, so that's one thing. And another thing I added is actually my overhangs for our for the roof. So let's take a look at it. So by default, our roof shedding was exactly the same length as our roof, and which is not actually realistic, because usually the roof is a little bit longer roof overhangs over the wood pieces. So for that, so for the gable side, what you can do is go to the roof shedding part, and where we basically created our board from connect opposite side. And if you remember, we also created our post process option to make our polylines longer or shorter. So just subtract like 2 centimeters from it, and that's how we get our overhang on the gable side. And for the other side, we have to do a little bit more of an involved setup. So take a look at this one. So inside here, it's basically starts from the whenever we created our base roof, then we extruded the sides of it. This is how long we want our roof to be. So, and after that, I basically just copied this attribute triangle again with the same code, and I just made it longer, so offset it by the same 2 centimeters. So this roof is now going to go to our roof creation part, which is inside here. And then I went ahead and made sure that I create a reference poly extrude from this node and close it up, because we want to make sure that our gable side is also the same length to it, like that, and use the same dissolve node like it's here. So basically, after we have made our roof a little bit longer, we do the same 2 processes inside here. It basically mirrors this one that creates our shedding, but inside here, since it is a little bit longer, we create our roof a little bit longer, and then we connected that one up like that, and that's how we got our overhang from here like that. So these are 2 parts that you can use to make your roof a little bit longer, so that it looks a little bit better like that. So I think I'm going to end this part, because right now we're basically done with the creation of the geometry, and now we have to clean this up, give some polygroups to it, and also UV unwrap it, add some materials, and that will be it. Okay, so see you in the last video.